A circle center O is divided into two sectors by radii, OA and OB. The ratio of the area of the minor sector to that of the major sector is 1 to p, and the angle contained in the minor sector is theta radians. Show that theta equals 2 pi over p plus 1. Even though the sector angle, theta, was given in radians, we will first prove this result where theta is measured in degrees, and then in radians. It isn't at all necessary to show the former, but it is useful nevertheless to know how to approach the problem in a different way. The area of a circle equals pi r squared. Since a sector is a smaller area of a circle, which is bound by two radii in the circumference, and a complete angle is 360 degrees, it follows that, by proportion, the area of a sector is pi r squared, times theta over 360. In the case where the sector angle is 360 degrees, the area of the sector becomes the area of a circle. When converting degrees to radians, note that pi radians is equivalent to 180 degrees, which means that 360 degrees is equivalent to 2 pi radians. The area of the minor sector of this circle equals pi r squared, times theta over 360. To simplify the problem, we will call the angle contained in the major sector, alpha. The area of the major sector of the circle therefore equals pi r squared, times alpha over 360. Note that this formula for the area of a sector is applicable when the sector angle is measured in degrees. We can now formulate an expression for the ratio of the area of the minor sector to that of the major sector. We are given the ratio of the areas of the sectors of the circle, therefore, 1 over p equals theta over alpha. Cross-multiplying gives us alpha equals theta times p. Now, alpha and theta collectively form a complete angle, which is 360 degrees, or 2 pi radians. Thus, alpha equals 2 pi minus theta radians. Taking all terms containing theta to one side of the equation, and solving for theta, gives theta equals 2 pi over p plus 1, which is what we were required to prove. The area of a sector, when the sector angle is measured in degrees, equals pi r squared, times theta over 360. Since 360 degrees equals 2 pi radians, the area of a sector, where the sector angle is in radians, is given by a half r squared theta. So the area of the minor sector equals a half r squared theta, and that of the major sector is a half r squared alpha. Regardless of the approach you take, whether you work in degrees or radians, be sure to use the relevant formula, and/or conversions, as required.